Today, we're counting down 10 of the most terrifying cosmic and planetary threats that could end life as we know it, ranked from the most immediate to the most inevitable. Some of these might surprise you. Some will keep you up at night. Let's get into it. Look up at the night sky. It's beautiful, isn't it? Peaceful, quiet. But here's the truth. That sky is full of things that could end us. Not in some distant science fiction future. In geological terms, some of these threats are practically knocking on our door right now. Earth has already survived 5 mass extinction events. 5 times, life on this planet was almost completely wiped out. And every single time, it wasn't because of something we did. It was because the universe decided to remind us how fragile we really are. Let's start with the one you've probably heard of, but maybe don't take seriously enough. 65 million years ago, a rock roughly 10 kilometers wide slammed into what is now Mexico's Yucatan Peninsula. The impact triggered wildfires across entire continents, blasted enough debris into the atmosphere to block out the sun for years, and wiped out roughly 75% of all species on Earth. The dinosaurs didn't stand a chance. Now, here's the uncomfortable part. It could happen again. NASA and other space agencies currently track thousands of near-Earth objects, and while none of the ones we know about pose an immediate threat, the key phrase there is the ones we know about. In 2013, a meteor exploded over Chelyabinsk, Russia, with the force of 30 Hiroshima bombs. And we had absolutely no warning. Planetary defense programs like NASA's DART mission are making progress, but we're still nowhere near ready for the big one. This one doesn't get enough attention, and honestly, that's probably because there's nothing we could do about it. Gamma-ray bursts are the most powerful explosions in the known universe. They occur when massive stars collapse, or when 2 neutron stars merge, and for a few seconds, they release more energy than our sun will emit in its entire lifetime. If a gamma-ray burst were to occur within a few thousand light years of Earth and to be pointed directly at us, it would strip away our ozone layer almost instantly. No ozone layer means no protection from UV radiation. Crops die. Marine ecosystems collapse. The food chain breaks down within years. Some scientists even believe that a gamma-ray burst may have triggered one of Earth's past mass extinctions, the Late Ordovician event, about 440 million years ago. The terrifying part? We'd have no warning, no time to prepare, just a flash of light, and then the slow unraveling. In 1859, a massive solar storm hit Earth. At the time, the most advanced technology we had was the telegraph, and even those machines caught fire and shocked their operators. That event is known as the Carrington event, and if something like it happened today, the consequences would be almost unimaginable. A solar storm of that magnitude would knock out power grids across entire continents. We're talking about transformers that take years to manufacture and replace. No electricity means no water treatment, no food distribution, no hospitals, no communication. Studies suggest that a Carrington-level event today could cause up to $2 trillion in damage in the US alone, and leave hundreds of millions of people without power for months, possibly years. And here's the kicker. Solar storms are a regular occurrence. The sun fires them off constantly. We've just been lucky so far, but our luck won't hold forever. You probably think of volcanoes as localized disasters. A mountain explodes, lava flows, people evacuate. Tragic but contained. Supervolcanoes are something else entirely. Right now, beneath Yellowstone National Park in Wyoming, sits one of the largest volcanic systems on Earth. Its last full eruption, about 640,000 years ago, blanketed North America in ash, and almost certainly triggered a volcanic winter. A period of global cooling caused by ash and sulfur dioxide blocking sunlight. An eruption of that scale today would devastate agriculture worldwide. Crop failures across multiple growing seasons, global food shortages, mass migration, the collapse of economies. And Yellowstone isn't alone. Similar systems exist in Indonesia, New Zealand, and Italy. Scientists say the probability of a Yellowstone super eruption in our lifetime is extremely low, less than 1 in 10,000 in any given year. But extremely low is not impossible, and the consequences would be planetary. Right now, Earth is protected by an invisible shield, its magnetic field. Generated deep within our planet's molten core, this field deflects solar radiation and cosmic rays that would otherwise bombard the surface. But here's something most people don't know. Earth's magnetic poles have reversed hundreds of times throughout history. North becomes south, south becomes north. And during the transition, the magnetic field weakens dramatically, sometimes to just a fraction of its normal strength. The last full reversal happened roughly 780,000 years ago, and scientists have noticed that Earth's magnetic field has been weakening at an unusual rate over the past century. During a weakening or reversal, increased radiation could damage satellites, disrupt power grids, and expose life on the surface to higher levels of cosmic radiation. We don't know exactly when the next reversal will happen, but the data suggests we may already be in the early stages. This one sounds like science fiction, but it's taken seriously by some of the world's leading astrobiologists. The theory of panspermia suggests that life, or at least the building blocks of life, can travel through space on meteors and comets. Microorganisms have been found surviving in incredibly hostile environments, inside volcanoes, in the stratosphere, in the vacuum of space. Now, imagine a meteorite carrying an unknown microorganism crash landing on Earth. Or, perhaps more likely in the near future, astronauts returning from Mars or the Moon, carrying a pathogen that no human immune system has ever encountered. We have no antibodies for something that didn't evolve here, no natural immunity, no existing treatment. NASA takes this seriously enough to have an entire Office of Planetary Protection dedicated to preventing biological contamination, both from Earth to space and from space to Earth. As our exploration of the solar system accelerates, this risk isn't going away, it's growing. Space is mostly empty, but it's not static. Stars move, and occasionally, a star passes close enough to our solar system to cause some very serious problems. In about 1.4 million years, a red dwarf star called Gliese 710 is expected to pass within less than a light year of our Sun, close enough to gravitationally disturb the Oort cloud, the vast shell of icy objects at the outer edge of our solar system. That disturbance could send a barrage of comets hurtling inward toward Earth. Now imagine something even more extreme, a rogue black hole drifting through the galaxy with no star to reveal its presence. No light, no warning, just an invisible mass of gravity warping the orbits of everything around it. The odds of such an encounter in human timescales are astronomically low. But over millions of years, the solar system has almost certainly had close calls we'll never know about. A gamma-ray burst isn't the only stellar disaster that could ruin Earth from afar. If a massive star were to explode as a supernova close enough to our solar system, the results could be devastating. We're talking about an explosion so powerful it could briefly outshine an entire galaxy. A nearby supernova within roughly 30 to 50 light-years could flood Earth with high-energy radiation, damage the ozone layer, and expose the planet to dangerous levels of ultraviolet radiation for years. That would put ecosystems under extreme stress, especially in the oceans, where the base of the food chain is incredibly vulnerable. The good news? There are no known stars currently poised to go supernova that close to us. The bad news? The galaxy is old, violent, and full of stars living on borrowed time. Over long enough timescales, supernovas are not rare events. They're inevitable. Not every planet dies in a sudden explosion. Some are slowly pushed past the point of no return. A runaway greenhouse effect happens when a planet's atmosphere traps so much heat that the process feeds itself. More heat means more water vapor. More water vapor means even more heat gets trapped. Eventually, oceans evaporate, surface temperatures skyrocket, and the planet becomes unrecognizable. Venus is the nightmare version of this process. It may once have had oceans. Today, it's hot enough to melt lead. Earth is nowhere near becoming Venus tomorrow. But planetary climates can change dramatically when pushed hard enough by solar evolution, atmospheric disruption, or cascading feedback loops we don't fully understand. Life on Earth depends on an extremely narrow balance. And the terrifying thing about balance is this: you usually don't realize how fragile it is until it's gone. Here it is, the one that's not a possibility, it's a certainty. In approximately 5 billion years, the sun will exhaust its hydrogen fuel. As it does, it will expand into a red giant, growing so large that it will engulf Mercury, then Venus, and almost certainly Earth. At that point, any life still clinging to this planet will be incinerated. The oceans will have boiled away billions of years earlier. The atmosphere will have long since been stripped. Earth will be a scorched, airless rock swallowed by its dying star. Now, 5 billion years is an almost incomprehensible amount of time. Our entire species has existed for just a few 100,000 years. So in practical terms, this isn't something to lose sleep over tonight. But it is a reminder that in the universe, nothing lasts forever. Not planets, not stars, not solar systems. Everything ends. The question is what we do with the time we have.